On today's Emerging Tech Horizons, what is GPS and how do you spell it and why you should care? Hello and welcome to the Emerging Tech Horizons podcast. I'm Arun Serafin, Executive Director of NDIA's Emerging Technologies Institute. Today's episode, we're going to discuss the role of the Global Positioning System, or GPS, and Emerging Position, Navigation, and Timing Systems, PNT systems, in U.S. national defense. For decades now, GPS has underpinned every aspect of American military missions, from guiding munitions to their targets, to tracking locations of U.S. military assets, to basic navigation. However, GPS also faces emerging threats, which include advanced jamming systems that can deny the U.S. military access to this GPS network, or even the shutdown and destruction of GPS systems in space, the satellite systems. These challenges require investments in backup systems ranging from onboard PNT to the ability to network with other satellites or ground networks or platforms in theater. To discuss this and related topics, we're honored to welcome Dr. Alison Brown to the podcast. Alison is an old friend and colleague of mine, and it's great to have her here. She's President and CEO of NDIA member corporation, the NAVSYS Corporation, which is working to shape the future of PNT. Alison, thanks for joining us on the podcast.
Well, thank you for inviting me.
So I know you have an extensive background in the world of aerospace and defense, as well as a technical background. Could you tell us a little bit about your background and your career journey?
Absolutely. Well, I actually grew up in Scotland. I'm a graduate of Cambridge. I did engineering there. And then I was lucky enough to be given a scholarship to come to MIT, which is how I ended up in the United States. And my father was actually a preeminent navigator in the United Kingdom. He won the gold medal from the Institute of Navigation. And he pioneered some of the very first inertial navigation systems. So I grew up driving to school with him, and he'd tell us stories about moving maps and SATCOM stabilization that he was doing. And was really excited about a career in navigation. So when I started studying at Cambridge, I was studying the transit system, which is the precursor to GPS, and got very excited about the opportunities with GPS. So I took the opportunity at MIT to do my master's thesis on that. Then ended up being lucky enough to get a career in it, got my PhD at UCLA, studying GPS, and got in right on the ground floor of a really exciting technology area.
We recently, at the Emerging Technologies Institute, did one of our Tech 101 educational webinars on GPS 101. And so just sort of stepping back historically, you talked about the transit system predating GPS. So help me out here. When was the GPS system put into place?
Well, I'm not sure I could give you the exact dates. I was at the Draper Labs in 1980, and they had just a handful of GPS receivers that were available at that time. It was a single channel receiver, a whole rack of equipment. So we had an initial constellation there and very few receivers going through evaluation.
So that's early 80s, late 70s.
Yes.
And prior to GPS, what was the transit system?
Well, at that time, transit was still the preeminent system because GPS wasn't near operation at that time. And it was the Navy navigation satellites. And basically, it was a Doppler-based navigation solution.
Which means?
Which means that you could basically get a two-dimensional fix from it. It was tracking a Doppler carrier. Came kind of derived from the old Sputnik system. The Russians' very first satellite, Sputnik. I think it was the Applied Physics Lab actually tracked that and located the satellite from tracking its Doppler. And then somebody had the brilliant idea that, well, if we knew where a satellite was, we could track the Doppler and locate ourselves. So transit was kind of the inverse of the Sputnik early tracking.
And then even before that, prior to Sputnik, prior to transit, is this basically celestial navigation? That, if you know where a star is, you know where you are?
I would think of an earlier analogy was actually the radio star. They were using that for surveying for quite some time. Cross correlations, very long baseline interferometry. That was probably closer to the technology.
So what is that? Help me out.
There's radio stars, pulsars. They broadcast radio signals. And if you pick up those two radio signals on two antennas, say they're 100 miles apart, you can get the relative phase between the two signals, and they were using that for surveying.
And so you could know where you were on the Earth based on knowing where the pulsars were?
You could know where you were relative to another
thing
antenna.
Okay.
Yes.
Oh, wow, that's really interesting. So today then, give us a little background. What's GPS doing for the military? How does it, I think, help us, communicate, find our place on Earth? Everything from my cell phone to an F-35.
Well, GPS it's a PNT system, position, navigation, and timing. So let me start with the timing, because that's kind of sometimes the most underestimated part, but maybe the most important part of GPS. So pretty much any satellite communication system today that the DoD uses needs timing. Any electronic warfare system needs timing. So in order for the DoD networks to operate, in order for the EW systems to operate, they have to have a precise time reference, which GPS is integrated into all of those systems. Positioning, obviously, blue force tracking. Imagine if we didn't have awareness of where all our own forces were. Navigation of aircraft, ships. There's a story I always enjoyed early on, which was there was a lot of debate whether or not using GPS was going to be cheating in exercises such as Red Flag. Red Flag's the big training exercise in NELS. And so they did allow it to be used. In the early days, there were protocols where, of course, you train on how to connect to a tanker for refueling. So you're given a waypoint and both have to navigate and arrive at roughly the same time for refueling. Well, after an incident on one of the first tests of that, a new protocol was derived, which said, do not give the tanker and the aircraft the same coordinate.
Because I was deemed an unfair advantage.
No, because they almost collided. They went to exactly the same place, which had never really been a problem before.
Oh, interesting.
Yes.
Okay.
So anyway, there was all sorts of discussions. Whereas, is this really going to be valid for training if we allow our pilots to take advantage of it? Changes in operational procedures, just because of things like nobody ever anticipated you would go to exactly the same point within a meter of each other.
Right.
And it really has totally changed, the operations of the DoD. Integration's always been an issue, and one of the stories I always enjoyed was how GPS actually got installed in most of the early aircraft. And, today this is still an issue. Reintegrating alternative PNT solutions or even upgraded GPS solutions, anti-jam antennas on current aircraft, huge issue on any platforms, in fact. And so what they did in the very early days was all of the aircraft had a sextant port.
Okay.
And it was literally just a bubble on the top of the aircraft.
Right.
And the sextant port had power because they had to defrost the bubble.
And was that used for the pilot to
No, it was used for the navigator. The navigator would go back.
The navigator to use an theoretically old-fashioned sextant?
It wasn't theoretically. That's how they navigate.
Okay.
That's what they did.
Okay,
but every aircraft had the sextant port.
Right.
And so the very first GPS receivers, they put the antennas in the sextant port and powered them from the power that went to the sextant port.
Right.
So the reason GPS got integrated early into many, many aircraft was because of the sextant ports.
It was a place to put it.
It was a place to put it, and it had power. It didn't require putting another hole in the aircraft.
Okay. So now, thinking about this today, GPS is only one of lots of options for PNT.
There really are very many other options that will give the same performance as GPS.
Okay.
So it's certainly being used in addition to other options, but without GPS, it's a huge challenge getting the same type of performance and precision.
So then, I guess the question then is, we always worry about this GPS denial, and that threats will take out our GPS system. So how exactly could our military be denied access to this GPS network and the position information, the timing information that you're talking about?
Sure. Well, the most straightforward way is just through jamming. Basically GPS is a very weak signal. It's coming from a satellite. It's
down to your receiver, your car, in your cell phone, in your F-35.
Yep. And so if there's a high-powered jammer in the area, and basically they're just blasting the frequencies that GPS is operating on, and there's only two frequencies, L1 and L2, then that can take out the GPS
And everybody
signal.
knows what they are?
Absolutely. Yep.
And so the jamming then just prevents me from hearing the signal. It doesn't do anything to the satellite.
Mm-hmm.
The signal's still there. I just can't hear it.
Correct.
Okay.
Yes.
I'm assuming you could also take out the satellites.
That's harder. And then there's also, at what point is an attack on our or our allies' space assets, such as GPS, would that, for example, engage NATO if that happened, if an enemy took that step? So it's certainly technically feasible, not straightforward, but it certainly could be done. But the impact it wouldn't just be a huge impact on DoD. It would be an impact internationally, because of the reliance on GPS, and could potentially have very severe consequences, analogous to an attack on the U.S. mainland.
So on the international front then, tell me about other countries. Does everyone depend on our GPS network? Are there multiple GPS networks for different countries?
Other countries have implemented what are more generally termed to as global navigation satellite systems, which are their own variants of GPS. There's the Galileo system, which was put up by the EU. The Russians have a system called GLONASS, also publicly available, so you can use that. The Chinese has a system called Beidou. And then there are the Japanese, I shouldn't forget them. They have quasi-zenith satellite systems. So they have an own system.
And they all basically are about the same quality, the same functionality?
Well, we like to think ours is better.
Okay.
But yes, very similar type of performance, and maybe not as many satellites, but yes, similar types of performance.
And so then threats to GPS or these other systems would also have an impact not just on the military, but on civilian critical infrastructure as well.
Absolutely.
For example, what?
Transportation systems. Basically, all of our aviation systems today rely on GPS for navigation. We do have backups. If GPS went down, the air traffic control system is designed to be able to take over, but it's designed to take over to get the aircraft on the ground, not to keep the traffic in the air.
Right.
So the impact would be huge on transportation. Maritime, logistics, shipping.
Have we ever seen the GPS system go down?
We have, actually. Good question. There have been some glitches. I'm not let me think about it. I might remind you. I might remember one or two, but there have been very, very few. But on occasions.
And how long did they last?
Well, it wasn't the whole constellation. It might have been a satellite or two. Historically, they would have been reported in NOTAMs. It's NOTAM. I keep forgetting what. They report all navigation outages.
Oh, okay.
Present or past. So there would have been some, but there have been occasions where there have been glitches.
But this is for hours.
Yeah, or if even that long.
Okay.
And this is in the many, many, many decades the system's been operating.
Right.
It's really been incredibly reliable.
Okay, and then have we seen publicly that GPS has failed due to jamming?
Oh yes, many times.
For example?
Well, you can go to a public website. It's called gpsjam.org.
Okay.
It's actually operated. There's one of the transportation systems that's incredibly important is called ADS-B, Automatic Dependence Surveillance B.
Okay.
All right, and it's really kind of the Blue Force tracking for commercial aircraft.
Okay.
And it reports out over a satellite service location, but it also reports the quality of signal,
right,
which is based on GPS.
Right.
So there's a whole amateur group that is public information, and they track this ADS-B. I think there's been reports of where Elon Musk is, in his areas,
okay.
that kind of
Billionaires'
stuff.
yachts and stuff like that. Got it.
Well, that's surface, and there's
Yep.
another system called ADIS that does surface, but the aircraft is ADS-B.
Got it.
And so the GPS-Jam.org has taken this public information, plotted on a map where position degradation, as reported by GPS through ADS-B, is degraded.
Yeah,
And
and we think that's due to jamming.
Yes. From the DoD's perspective, we know it's due to jamming, but this is public information, and it's just from seeing where...
Is jamming a pretty low-tech thing to do?
Very low-tech.
Very low-tech.
Yeah.
Okay, so let's think about then anti-jamming.
Yes.
What are some of the approaches to deal with this relatively low-tech threat?
Well, the anti-jamming solutions that have historically been used are, nulling antennas. They're called SERPAs, Controlled Reception Pattern Antennas.
Which do what?
They use multiple antennas, and then they basically use algorithms to put nulls from the antenna in the direction of where they're sensing power.
Uh-huh.
And that weakens the jammer signal.
It jams the jammer.
It actually weakens it, attenuates it. So you can, if you attenuate the jammer enough, then you can see the signal again. Right. So that's one technique. The problem is that basically if you have, 7 antennas, the theory is you can put nulls in 6 directions. And so if you have more than 6 jammers, then you kind of run out of options. And also when you start putting...
It's sort of an escalatory game, right? How many
Yes.
jammers can I put? Okay, got it.
And also, the more nulls you put out, well, you're not just nulling a jammer in one direction, you're nulling all the satellites that are in that direction too.
Right.
So you start seeing less and less and less satellites, which degrades your accuracy, even if you can track the signals.
Right. What other anti-jamming techniques?
Well, the old stuff that my father used to work on, which I still work on myself, inertial navigation. And those basically are dead reckoning devices, accelerometers, gyros, and you can't jam them.
Right. So you know which direction you're going, you know how fast you're going or accelerating, and this keeps telling you if you stay on this course, here's where you're going to be.
Exactly. And so if you use those, then they can't be jammed, but the trouble is they drift over time. They drift quite a large amount. I mean, back in my father's day, we measured GPS in terms of meters of accuracy. Mm-hmm. His quality, his measure of quality was miles per hour. Right. And the inertials today, they've got a lot smaller and cheaper and lower power, but they really are not necessarily any better quality than the ones that were built.
But
back then.
There's inertial navigation systems like, I'm no expert, ring laser gyroscopes, right? The stuff that goes in nuclear systems.
Yes.
Those drift rates are really, really low, right?
Exactly.
They stay on course, they lose, micrometers per hour. Am I right?
Sure, but most people can't afford
them.
or have the batteries to run them.
Got it.
I mean, your cell phone has an inertial system in it today.
But for the high-end systems, okay.
Yeah.
So, in your view, what else does the Department of Defense need to do to de-risk itself in the face of potential GPS threats?
Well, they have made an investment to say that we are going to put what are called assured PNT devices on every platform. And so that is putting an inertial and also a clock. And interestingly enough, the clock technology has gone gangbusters. I mentioned inertials. We aren't necessarily seeing anything affordable that's much better accuracy, than historical systems. Mm-hmm. They've just got cheaper, lower power, more accessible. But the clocks have got dramatically better. I mean, you can literally get a clock now, affordable, maybe a few $1,000s, and put that on a platform that is about as good as what was flown on the first GPS satellites.
And when you say clock, what do you mean?
They're atomic references, and basically they will hold time to a very high level of stability, like nanoseconds a day. And the nanoseconds are foots, whereas inertials are measured in terms of miles per hour. A 1 mile per hour is a pretty good inertial.
Right.
You can have a clock that's a nanosecond a day or a foot a day.
Okay.
All right. And of course, with any kind of PNT system like GPS, if you can, you need 4 satellites in order to navigate, but if you have good time, you only need 3. So those are very good types of augmentation or aiding sources.
And these are potentially useful even during military operations.
Yes,
Right.
yeah, absolutely. And more importantly, too, one of the things that the DoD's done is, they've adopted what's called modular open architecture standards. And PNT, I think, is one of the shining lights of how, that has been done well. And, historically, what they've done in the past when they've gone and bought a fancy navigation system like for an F-16 or whatever, is that they'll buy it as a total system. And if you want to go make any changes to it, so even when they're minor changes, very expensive, very hard to do. So when they bought these assured PNT devices, and they're already getting installed and deployed on different platforms and different configurations, they also said, we're going to own all the interface standards, the DoD, and we're going to open up those interface standards. So if you are building, an extra special gee-whiz, super-duper navigation solution that can augment, for example, in certain areas, through these open standards, you can give that data to the inertial navigation system for it to be able to be updated.
Right.
So in other words, without spending millions of dollars every time you want to do an improvement or an enhancement through this open architecture, if they add on a different system, like one of the ones that are being, really starting to get on a lot of platforms, vision-based navigation systems, they can be used to update the inertial navigation system in the absence of GPS without having to go all the way back to the prime contractor in a long...
And out of curiosity, those open standards, are they also being embraced by the commercial side as well?
The commercial world has always been a little bit better on that, in my opinion. Like for aviation, it's all standards-based.
Right.
So
they've been ahead of us on the military side. The commercial side's been ahead on this.
In my opinion, yes. And in fact, bragging rights, NAVSYS, we came up with one of the first open architecture inertial navigation solutions. It's called InterNav. We first developed it about 30 years ago, kind of ahead of its time. And since 20 years, it's been installed on thousands and thousands of platforms. And a lot of our commercial partners really liked that solution because they could compete at the component level for building their systems. As an example, one of our customers, FLIR Systems, they build these very super electro-optic IR products, and they use inertial devices for stabilizing. Well, they were using, there's only a limited number of companies that build the quality devices, and at that point they were using a combination of Northrop devices for some products and Honeywell devices for other products. But what they were finding was anytime one of those contractors won one of the big defense contracts, like they actually won the contract to put their inertial devices on a munition like JDAM, their production line stopped for the commercial vendors because the DoD got priority.
Got it.
And from a commercial manufacturing point of view, that's a killer.
Yeah.
You can't sell your product because you can't get this component, and you're getting bumped off the production line for that component because the DoD's has preempted you.
Right.
So by going to this open architecture solution, which is what InterNav was developed to do, they could compete source of suppliers.
So it's helpful for the supply chain on those dual use areas. Another example of why standards aligned with the commercial sector makes some sense.
Exactly. Right? Yes.
So, when thinking about some of the emerging technology areas, autonomous systems, which can be air, ground, undersea, surface, this future of PNT, and how does it tie into this vision of things like the replicator program, right? Hundreds, thousands of drones. Is that vision, does it require this future PNT, or can we do it with what we've got going in GPS?
Boy, for something like replicator, there are multiple challenges. So I'm going to hone in on two that are really key to GPS right now. So I mentioned how the military's been making investments to improve the military technology and anti-jam. They have a new signal called M-code, which gives improved jamming performance. It's crypto equipment. So when you start putting crypto equipment on unmanned autonomous platforms that could very easily be captive, these are controlled devices, tamper protected, And this has just been a continuous problem with GPS. Like I remember this when we were looking at unattended ground sensors. Getting military equipment on was pretty much impossible operationally. So what started happening, even though there's actually a DoD directive that says ye shall use military GPS if you are DoD, it turned, and there was a waiver process put in place that you had to go get a waiver. There's so many applications out there that are still using civil GPS. And one of the issues is just the security. Because the security architecture, operationally, how do you put that kind of device onto these platforms? Okay. Then the other question is cost, and weight and power. These devices are, I'd hesitate to call them exquisite because they're quite old technology now, and the commercial navigation solutions have really leaped ahead. But they're designed to basically go into an acquisition process and have a supply chain and be able to be supportive for like the next couple of decades,
right.
At least a decade.
Right.
The commercial world doesn't work like that. So they're refreshing every few years.
Right.
And so
there's no point in having an open system that's open to commercial innovation if you've never bothered to replace these things.
Exactly. Yeah. So what's happening for a lot of these applications, I can't talk to exactly what's on Replicator, but the majority of these small, cheap unmanned systems are just using commercial, usually GNSS devices, which actually use GPS and other signals, the other global navigation satellite system signals. So those can be spoofed, which is even more dangerous than jamming. Because imagine if you could turn your unmanned surface vehicle around and send it back at the ship that was launched it.
So the dependence on commercial brings its own interesting challenge.
Oh, it's from a military perspective, it's an absolute nightmare. So it, in one way, even though we have better secure systems for the DoD, just the bureaucracy goes around using those security systems because of the crypto, the temporal protection, the way the keys are managed, makes even if you could build them cheap, and they aren't being built cheap because they're not enough quantity compared with commercial. They're not using them for those types of applications is a huge problem.
Okay, so you described some interesting technical challenges, operational benefits, policy/buying kind of challenges. So your company now, NAVSYS, what's your focus in all of this area? What are you working on?
Well, NAVSYS is a futurist company. I mean, we have got involved right at the ground floor of a lot of different really exciting technologies. We did the very first GPS cell phone. It's actually in the Smithsonian.
Oh, wow.
Yeah. But another solution we developed, we pioneered working with Inmarsat, was the wide area augmentation system. And that was where we took just an Inmarsat satellite and using what's called now, it's a bent pipe technology that we pioneered, we broadcast a signal through that satellite and controlled it, manipulated it so it looked to a GPS receiver like a GPS satellite. But it was just being bounced off. Yeah, everything was done on the ground. That was where all the magic was. And that's the foundation of the wide area augmentation system, the other satellite augmentation systems, space-based satellite augmentation systems that other nations run today. So what we basically were looking at is I mentioned some things like vision-based navigation. There's some other alternative navigation technologies that are being experimented with. But there's a reason GPS was developed, and that's because satellite navigation is fabulous. I mean, there really is nothing else that's been proven to be as good or better. Vision-based has a lot of potential in certain areas, but what you do when you're over the ocean, how does the surface vessel use vision-based? They don't have the same capability.
When you're talking about vision-based,
yes.
What are you looking at?
Landmarks, just like you do. You used to have a map and you'd look
sort of
at
dead reckoning.
Exactly.
Okay.
Yeah. Well, it's pretty sophisticated now. Like if you could still remember how to use a map, it's a lot like that still. But the artificial intelligence can do it.
And NAVSYS is typically a subcontractor to a bigger company or directly selling to the government or both?
No, actually, a lot of our work, it basically comes through the Small Business Innovative Research Program. SBIR. Because SBIRs tend to describe a problem.
Mm-hmm.
And so where we've been really successful is offering very innovative solutions into these problems. And then the nice thing from our perspective is we're funded to develop them. We actually end up with intellectual property rights from the development.
Right. It's one of the features of the SBIR program.
I'm a huge fan. It really is what allowed me to start and NAVSYS to continue doing the innovative work we do. But anyway, so let me progress. So there's a reason that satellite navigation is kind of the best solution. And it's basically you got ubiquitous access to all these satellites, think GPS, you got signals you can get very precise ranges off of, you can basically trilaterate, to get the location, and it works anywhere in the world.
Right.
All right, very, nobody else has really come up with a silver bullet that does those kind of things. So the trouble is GPS is a big fat target, L1, L2, people can jam it, it's easy to do. So there's been obviously interest in, well, can we do other satellite navigation systems? Can we operate in other frequency domains? And technically the answer is yes. Regulatory, the answer is no. And the reason is all to do with frequency allocations.
Okay. It's a spectrum.
It's spectrum issue, yeah. In that, they basically, the FCC, ITU, they've carved up all these frequencies into different chunks.
Right.
And the big gorilla now is SATCOM. You can get spectrum allocations like Starlink gets a nice big fat spectrum allocation for providing broadband internet, but you can't get access to those spectrums for doing just a little PNT function, even though, obviously it's considered important. It's
both militarily and commercially.
Exactly. Well, the military actually has even less access to frequency. They've been losing frequency allocations now for decades.
Yeah.
Yeah. So they're even worse off than they used to be 20 years ago.
Yeah.
So
the spectrum battles are continuous, ongoing,
and
I actually didn't think hard that PNT is a player in this.
Oh Lord, yes. Yeah. And the DoD is the tiny little monkey, not the big gorilla.
Right.
in this battle.
So we're gonna have to wrap up. My last question would be, it's a very exciting field. It's got a lot of potential.
Mm-hmm.
You've done a good job. What advice would you have for those engineers, scientists of the future who are thinking about working in this space? What would you tell them to have a career as successful and interesting as yours?
Well, there's all sorts of interesting applications. I just quickly let me summarize. The reason I was talking about SATCOM is we've actually developed a way to use those SATCOM signals for PNT.
Okay.
So it's to do with, there's some very special algorithms, radios, software-defined radios now. They're amazing what you can do with that, completely reprogrammable. Open architectures, artificial intelligence, machine learning. You might not think that those would necessarily lead to a career in PNT, but they actually do. So one of the things that's been most exciting in my career is just watching the evolution of all the technologies. And one of the reasons we've been successful with NAVSYS is we've been early adopters for using a lot of these different types of technologies.
Right. And you're absolutely a platform technology, which then enables all those other different innovations to run forward.
Exactly.
Because you're providing sort of basic information, position, time, those sorts of things.
Exactly.
Yeah. So with that, I want to thank Dr. Alison Brown for joining us today on the podcast and for this informative lesson on GPS and PNT. I want to take this opportunity to highlight a couple of upcoming ETI events. Our second NDIA Emerging Technologies Conference is going to be held August 7th through 9th at the Washington, D.C. Convention Center. I hope you're going to come there. We've got great keynotes lined up. Deputy Secretary Hicks, she announced a replicator program at our last event. We've got Admiral Grady, the Vice Chief of the Joint Chiefs of Staff, Undersecretary Hsu and LaPlante, Service Acquisition Executives, all three Undersecretaries from the three services, the DIU Director, many others. There's great opportunities to present for companies, to exhibit in our display hall. go to our website, ndiatechexpo.org, for more information on the conference. We also have our drumbeat of our ongoing monthly Tech 101 series, as well as our webinars and other activities all the time from ETI. Please check out our website and the NDIA website for more information on those. To register for any of our events, you can go to ndia.org/events. And you can also visit our website to read our reports. For example, most recently, our Directed Energy Sourcebook. Thank you so much for tuning into this week's episode. If you've enjoyed this podcast, please hit the like button and subscribe to our channel to stay up to date with all of our latest content. You can email us at eti@ndia.org with your questions, comments, or ideas for future podcast topics. Special thanks to Daniel Park and Melanie Yu for producing this podcast. Thanks again to Alison for joining us today. See you on our next episode of Emerging Tech Horizons.